All right, guys, here we are. We're going to be tapping into 4-7 today, which is transforming formulas. So we're going to be solving equations, but those equations aren't just going to be solving for like x equals 7. It's going to have multiple variables in there. So sometimes can prove a little challenging for people as they're trying to navigate solving an equation, but also having other variables other than just having one variable in there. So we'll get right into it. We will solve, this is 4-7, solving, or it's actually called transforming formulas. Okay, so with this, what they're going to give you is, they're going to say solve, and then they're also going to state, state any restrictions. I'll talk about that here. So they're going to give you something like this. It's going to say f equals ma, and then they're going to have this other variable a sitting out there. So what they want you to do is they want you to solve this equation here, and then they're telling you which variable they want you to solve it for. So they want you to solve for a. So solving for a means we're going to have a by itself, and then everything else on the other side. So we look at it, and then we just solve it using the same methods that we've done in solving other equations. And we would say, okay, f is equal to m times a, and in this case, we are going to look at what's attached to the a. M is attached with multiplication. So I'll rewrite this down here. We are going to divide both sides by m, and when you divide both sides by m, they cancel on the right side here. And you have f over m is equal to a. The symmetric property allows for you to switch, so you have a is equal to f over m. And then you would be done. A is by itself, and it's in terms of f and m over here. Now, the book states something. It says, hey, state any restrictions. The restriction is this. If you look at the fraction here, f over m, and you know anything about fractions, we know that if you have 7 divided by 0 or whatever, 6 divided by 0, you can't divide by 0. So if the denominator is 0, that's an issue. You can't do that. So when we look at f over m, we say, well, what can m not be? Because we can't divide by 0. So we would state a restriction. We would say m can't be 0. So m can't be 0. Usually what I do is, if we get to here, that's the most important. If you can state the correct restriction, I usually give that as like a bonus for that. So our goal here is to get the equation solved for, and then I'll let you know if we're going to make it a bonus, but try to work on the restriction, saying the denominator can't equal 0. But if we struggle with that, I may adjust and say that's just a bonus part to the problem. So, okay, let's go ahead and look at another one here. If I have capital A equals capital P plus capital P R T, and we are going to solve for variable t. All right, so as we take a look at this, we want to solve for variable t, and we look here, we have a p and a prt, and so the first thing we want to do to solve for t is we need to get rid of things that are attached to it. But we can't divide the pr out until we deal with this p first. So just like our other orders of operation, we need to add, subtract, and then multiply, divide when we're solving. So the first step is to get rid of this p. So we're going to say, okay, a, and when you subtract p from both sides, minus p. I can show that step right there. A minus p is equal to PRT, like that. Now we look at the t, and we say, okay, I want to solve for t. What is attached to the t? The p and the r are attached to the t, and so you're going to divide both sides by PR, divide by PR, and you would have then those cancel, and you're just left with a t on the right side. You have a minus p over PR. And then we rewrite that as t is equal to a minus p over PR. Some people want to, at this stage, they want to take the p and cancel here and here. But since it's attached with subtraction, we can't do that. So we have to leave it as such. We box it and call it good. Now the restriction is, in this case, I'll label this P can't equal 0 and R can't equal 0. Because if P was 0, 0 times anything is 0. If R was 0, 0 times anything is 0. And you can't divide by 0. So those would be the restriction parts for that problem. All right, let's take a look at number 3 and try another one. And if we go with, let's go S equals VT plus 16t squared, and we're going to solve for variable V. So it looks a little bit different because we have a square term in here. Let's see if we can solve for it though without any trouble. And so we take a look and we say, okay, I'm going to solve for V. I look and say, okay, I got t attached here. It's attached to multiplication. However, what we also want to do is I have to deal with the 16t squared. So just like over here, before you can divide by the PR, you had to get rid of the P. Before I can divide by the T, I got to get rid of the 16t squared. And we do that by subtracting 16t squared from both sides, like this. And you end up with S minus the 16t squared is equal to VT. So then on this, we would look and we say, okay, I have V times T. What am I looking to solve for? I'm looking to solve for V, so I'm going to get rid of whatever's attached to it here, which is the T. So you divide both sides by T. Those T's cancel to be 1, so you have S minus 16t squared over T is equal to V. Switching it around, we go S minus the 16t squared all over T. Again, here, people might want to cancel the exponent there with the T down here. You can't do that, okay, because it's attached with subtraction. Restriction, T can't equal 0. All right, let's cruise on, and I'm going to give you several examples because there's lots of different types of problems, and hopefully these will be helpful when you're working on your homework. So if we go capital S is equal to n over 2 times a plus L, and then we are going to solve for n. All right, so a couple of routes to go on this, neither right nor wrong. We want to solve for n. If we look at this, we have n divided by 2, and then also it's being multiplied to the a plus L. One thing I might do is get rid of the 2 first, so that we can get rid of that fraction part. If I have n divided by 2, since it's attached to multiplication here, I can just multiply the 2 out. I'm going to rewrite this so that we can see the steps I'm doing compared to the original, so a plus L. So if I take that and I multiply both sides by 2, I'll do it in red so we can just see. So if I multiply that by 2 and this by 2, these 2's are going to cancel like that, and you would be left with then 2s on the left side, and then those cancel, you're just left with n times a plus L. Now the temptation, I don't know if it's a temptation, but you might want to distribute the n in. Don't do that because we already have n by itself. It's not attached to, it's not in 2 different places, just n right there. It is attached with the a plus L, but it's attached with multiplication. So what I know then is to get rid of, and when I have multiplication, just like we did over here, we had v times t, I divided by t. In this case, I have n times a plus L. So to get rid of the a plus L, I'm just going to divide by a plus L. Divide by a plus L. So when I do that, a plus L over a plus L cancels to be 1, just like t divided by t cancels to be 1. So now I have 2s over a plus L is equal to n, and then I flip it around because the variable I'm solving for I like to have on the left-hand side, and then a plus L. Now here, the restriction that people sometimes do is they've gotten used to just saying t can't equal 0, p can't equal 0, r can't equal 0, m can't equal 0. The thing is here is, it would actually be fine if a was 0, because what if L was 2? 0 plus 2 is 2, you can divide by 2. So, or if L was 0, that'd be fine. If A was like 1, that's no problem. So it would be 1 plus 0 is 1, and you can divide by 1. So the restriction here is, remembering the denominator can't equal 0. So we could set this up and say A plus L can't equal 0, and then you would solve for either one. We would say in this case, if you subtract the L, A can't equal a negative L. And what that means is if A was 5 and L was negative 5, that wouldn't work, because 5 and negative 5 would give you 0, and you can't divide by 0. So this is the restriction you want. If that doesn't work out, if this is a struggle for you, just disregard it and don't worry about it. Okay, so disregard that part. Okay, let's go on to the next one here, number 5. And number 5, let's do A equals V minus U over T, and we are going to solve for V. Okay, so go ahead and write that one down. So A equals V minus U over T, and we're going to solve for V, and just do that. So if you have that V up top there, you are going to need to get rid of the things attached to it. The issue is I have V minus U over T. If you add the U to both sides, the problem is that the T is attached with division. So the first thing we need to do is actually get rid of the T before we can get rid of the U. So we have A equals V minus U over T. And so we're going to get rid of it. It's being divided. So we multiply both sides by T like that. The T's cancel. Now, usually they write the variable first that comes in the alphabetical order. A would come first. So a lot of times you'll have AT. If you write TA, I'm not going to mark you wrong. And then we take V minus U and we go ahead and add the U over because we're solving for V. So we're going to add the U over here. And we have AT plus U is equal to V. Switch it around, AT plus U. Now in that, since there's no denominator, there's no restriction because there's no division of 0 possible. So we just say AT plus U, and that would be as far as you would go with that. Okay, what about, let's do another one here. Let's do maybe just 2 more possibly. M equals x plus y plus z, x plus y plus z, all over 3, and you are going to solve for y. Okay, so we're solving for y. Now, on that, when you go to solve for y, you have to look and say, okay, we have x plus y plus z. Again, you can't just subtract the x and subtract the z because it's being divided by 3. And so the same way we couldn't just add the u, we had to get rid of the t first. We're going to do the same thing over here, is we got to get rid of the 3 first. And we get rid of the 3 by multiplying both sides by 3. So we go ahead, multiply both sides by 3, and get rid of the 3. So 3, and it would be 3m equals x plus y plus z. Now I didn't show the step, kind of, just like I multiplied both sides by t here, multiplying by 3, the 3's will cancel, and then we have 3m. And then we want to solve for y, we have an x and a z attached to it. So we're going to subtract the x, subtract the z. I'm going to do a double step like that. And we would say 3m minus x minus z is equal to y. And we switch it around, so y equals 3m minus x minus z. Again, there's no division, and so we do not divide anything. We're not dividing by anything, so there's no restriction for us, because there's no way to divide by 0 when there's no division there. All right, let's do one final one here, and then we'll call it good. You guys can get started on your H-dubs. And we'll call this one number 7 here. Board erase. And on that, then, this is number 7. I think the 7th one we're done. Let's go with this. L equals A plus n minus 1 times D, and we want to solve for n. All right, so take a gander at that one. L equals A plus n minus 1 times D. All right, want to solve for n. It's on the inside here. We see we've got a multiplication here. We've got an addition thing here. So break this down step by step. Let's do the first thing. The first thing would be subtract. Let's get rid of the A from both sides. Again, we can't divide by D because we've got the addition going right there. So you can't just divide only this by D. You also have to divide this by D, which would make it a little more messy. So the best thing to do would be subtract A first. And so you have L minus A equals n minus 1 times D. Now you could distribute the D in, but again, then you'd have to divide it out later. When you distribute it in, it would be ND or DN, then you'd have to divide by the D. So recognize that this quantity is multiplied by the D. You want to get rid of the D. Again, before you can add this 1, since this is a quantity being multiplied, you need to divide both sides first by D. So you would have L minus A over D is equal to n minus 1. And now our final step would be just add the 1 over. And since this is a fraction here, when we add the 1, it's going to be L minus A over D and then just plus 1 like that is equal to n. And we rotate it around, n is equal to L minus A over D plus the 1. And we could box there. The book might do a common denominator of D, so they might have L minus A plus D all over D. If you get it to this spot, that's going to be good enough. Now we recognize, oh, I've got something in the bottom. So D is in the bottom. What can D not equal? Well, in this case, there's only D. So we say, hey, D can't be 0, and that's our restriction. All right, so we've got a lot of problems shown here. And when you go through, utilize these to cross-reference and might help you with the steps of solving the equations that you're going after.